This video shows how to import the Mech-Mind example programs into a Siemens PLC and use them to test data exchange with the Vision project. The files to be imported are shown in the video. These files enable data communication between the PLC and the Vision system. Next, let's go through the steps. Import the Mech-Mind example programs. Build and download the PLC program. Check the status of data blocks. And run the PLC program to trigger the Vision project and get the results. Now, let's get started. First, import the Mech-Mind example programs into TIA portal. Make sure the project is in offline mode. Since it is currently online, switch it to offline first. Select PLC 1 in the project tree panel. Click Go Offline in the toolbar. The project enters offline mode. On the device view window, change the I addresses and Q addresses according to the actual requirement. This ensures that the Vision system, as a PROFINET slave, can exchange data with the PLC correctly. Here, set the starting address to 500. When changing the addresses, make sure they don't conflict with existing addresses in the PLC. After updating the addresses, import the camera I/O tag table. In the project tree panel, double-click PLC tags. Show all tags. On the PLC tags window, click the import icon. On the import window, locate and select the PLC tags table file. Click OK to import the camera I/O tag table. The window is shown in the video when the tags are imported successfully. Next, proceed to import other example programs. Still in the project tree panel, double-click External Source Files. Add new external file. In the pop-up window, locate and select the two files shown in the video. Click Open to import these files. Select the two imported external files and then right-click them. Select Generate Blocks from Source. A message saying that blocks can be overwritten will pop up. Select OK in the pop-up window. The functions and data blocks generated from external source files are shown in the video. Camera User DB2 is used to store user data. Camera I/O DB1 stores the input and output data exchanged between the PLC and the Vision system. In the project, to facilitate the maintenance of functions and data blocks, you can create a new group under Program Blocks. Select Program Blocks, right-click and select Add New Group. Name it as needed. Here, the group is named as 3D Camera. Select all the newly generated functions and data blocks, and move them to the 3D camera group. After importing the Mech-Mind example files into the PLC, it's necessary to build and download the PLC program. Click Program Blocks. Double-click Main OB1. Then, select the camera I/O FC1, and drag it to Network 1. Right-click PLC1 and select Download to Device, Hardware and Software, Only Changes. In the pop-up window, download the latest project to the PLC. At this point, the PLC program download is complete. Then, verify the status of data blocks. This is to confirm whether the downloaded camera I/O block can communicate properly. Before that, switch the project status to online monitoring mode. Select PLC 1. Click Go Online in the toolbar. Double-click Camera I/O DB1. Click the monitor icon. Expand the groups sequentially. In the group of From Camera, if the monitor value of heartbeat keeps changing, then the IQ addresses of the PROFINET slave in Mech-Mind peer have been successfully transferred to the camera I/O block. Finally, test the PLC program to trigger the Vision project and receive the results. In this scenario, the eye-to-hand camera setup is used, with a single Mech-Vision project. Thus, the PLC only needs to trigger the project and obtain the Vision results. Here is the main configuration steps. First, enable communication to establish the connection between the PLC and the Vision system. Then, enable Start Vision to trigger the Vision project to run. For easier testing, the parameters of this function block are divided into constants and variables. According to the command instruction, among the input parameters, there are three constants: the Vision project number, the number of poses returned, and the image capturing pose type sent by robots. These can be set manually. All other input and output parameters are read from or written to the corresponding variables in the camera user and camera I/O data blocks. This setup allows subsequent function blocks to exchange parameters and status between the PLC and the Vision system. Finally, enable Get Vision data to obtain the corresponding Vision results. Its configuration follows the same approach as Start Vision. For detailed information on the parameters, refer to the documentation about standard interface commands to complete the subsequent configurations. Next, let's move on to the actual configuration. Before testing, make sure the Vision project status is set to Auto-Load Solution. Then, enable communication in TIA portal. In Camera I/O, expand the group of to Camera. Double-click the monitor value of COM Enable. If a warning message pops up, click Yes to confirm changing the monitor value. Open the main program. In the project tree panel, double-click the main, OB1. Then, place the function block for triggering the project. First, insert a comparison command to manually trigger Start Vision when the specific variable reaches a set value. From the basic instructions, drag the equal instruction into Network 2. Then, open the camera user data block. Drag the variable step number to the input of the comparison instruction. Here, assume that when camera user step number equals 2, Network 2 will be executed. After that, drag the Start Vision function block to Network 2, and place it right after the comparison instruction. When finished, configure the parameters in this function block. Set the Mech-Vision project number to run the specified project. In this case, there is only one Vision project with a number of 1, so set the value to 1. Next, set the number of poses returned by the Mech-Vision project to get the desired results. In this case, all Vision results are required, so set the value to 0. After that, set the type of image capturing pose sent by the robot. This parameter specifies the pose type of the real robot to send to the Mech-Vision project. In this scenario, the camera is mounted in eye-to-hand mode and the project does not require images to be captured beforehand. Therefore, set the port value to 0, meaning no need to send the image capturing pose. Subsequently, set other parameters. In the project tree panel, click Camera User and Camera I/O respectively. From the Details View panel, drag the parameters to the corresponding input ports of Start Vision. The parameter configuration for Start Vision is completed. Then, place the function block for receiving the Vision results. Following the previous steps, drag a comparison instruction to Network 3. Here, assume that when camera user step number equals 4, Network 3 will be executed. Drag the Mech-Vision data function block to network 3, and place it right after the comparison instruction. In this function block, according to the instruction requirements, only the project number among the input parameters is a constant. Therefore, first set the project number to obtain vision results from the specified project. Note that the project number here should be consistent with the one configured in Start Vision. After that, configure the remaining input and output parameters. These parameters are still read from or written to the camera user and camera I/O data blocks respectively. From the Details View panel, drag the parameters to the corresponding input ports of Mech-Vision data. At this point, the program configuration is complete. Then, re-download the program to the PLC. In the Program Tree panel, right-click PLC1. Select Download to Device. Software, Only Changes. In the pop-up Load Preview window, click Load to download the changes to the PLC. Then, trigger the Mech-Vision project to run. Click the Monitoring On/Off icon. Enable Start Vision by setting camera user step number equals 2. Right-click the input side variable camera user Start Vision. Select Modify to 1, to trigger the Mech-Vision project to run. To check whether the triggering is successful, you can monitor the variable values in the camera I/O data block. Open the camera I/O data block. Navigate to From Camera. Check the value of status code. If it changes to 1102, it indicates that the project has started normally. If the returned value is different, refer to the relevant error code documentation for troubleshooting. Then, return to main OB1 and reset the variable camera user Start Vision back to 0. After the project has started, the PLC also needs to obtain the poses calculated by Mech-Vision. Enable Mech-Vision data by setting camera user step number equals 4. Right-click the input side variable camera user Get Vision Data. Select Modify to 1, to receive the vision results. You can still monitor the variable values in the camera I/O data block, to verify whether the vision result has been successfully obtained. Check the value of status code again. If it changes to 1100, it indicates that the vision points are obtained successfully. The data returned by camera user is shown as below. The pose data is stored in target pose. These values here represent the results of the vision project, namely the robot picking poses. For the specific numerical conversion relationships, please refer to the documentation for details. The above covers the import and testing of the Mech-Mind example program files. If you want the PLC to automatically trigger the Mech-Vision project and obtain vision results, please refer to the automatic control example MMS1 Vision Basic. More detailed operations for configuring PLC standard interface programs can be found in the documentation.